Hello everybody, welcome to A to Z Learning Hub. Today in this class we do some problems about error analysis. Find a relative error and of z is equal to a to the power 4, b to the power 1 by 3 by c d to the power 3 by 2. It is given percentage error of a, b, c and d are 4%, 3%, 2% and 1% respectively. You see, find relative error and percentage error of z is equal to a to the power 4 b to the into b to the power 1 by 3 by c d to the power 3 by 2. It is given the percentage error of a, b, c, d are 4%, 3%, 2% and 1% respectively. Now, your solution. A relative error of z, that is delta z by z is equal to what? 4 into delta a by a plus 1 by 3 into delta b by b plus delta c by c, because its power is 1, plus 3 by 2 into delta d by d. This is the relative error. Now percentage error is what? Delta z by z into 100 is equal to 4 into delta a by a into 100. This is the percentage error of a, plus 1 by 3 into delta b by b into 100. You multiply 100 on both sides, plus delta c by c into 100 plus 3 by 2 into delta d by d into 100. That is equal to, this is the percentage error of z, 4 into, this is your 4%, it is given delta a by a into 100, this is the relative error into 100, 4% plus 1 by 3 into 3% plus 2% only plus 3 by 2 into 1%. That is your what? That is your 16% plus your 1% plus percentage error of c is 2%, that is your 2% plus 3 by 2 into 1%, that means 1.5%. That is your what? 16 plus 2, that is your 18 plus 1, 19 plus 1, that is 20.5%. This is your answer. This is your relative error. Delta z by z is equal to 4, because its power is 4, delta a by a plus 1 by 3 into delta b by b plus delta c by c, because its power is 1, plus 3 by 2 into delta d by d. Then you multiply, and this part is your percentage error, this part. So 4 into 4% plus 1 by 3 into 3%, because percentage error of b is 3%, plus this is your 2% and this is your 1%, that is your 16 plus 1% plus 2% plus 1.5%, that is your 20.5%. This is your answer. Next come to your second question. Calculate the percentage error of in determination of a time period of a simple pendulum where t is equal to 2 pi root over of L by g. Here L is the length of a simple pendulum and your g is the acceleration due to gravity, and the percentage error of L is 1% and percentage error of G is 2%. You see, from this formula you can write solution. You see t is equal to 2 pi, you can write L to the power half by G to the power half. So delta T by T is equal to your relative error, that is your half into delta L by L plus half into delta G by G, because it is divided when, so their relative errors are added. So delta T by T into 100 is equal to half into delta L by L into 100 plus half into delta G by G into 100. So we can write your delta T by T into 100, we have to calculate it. This is the percentage error of a time period, is equal to half plus minus 1% and the plus minus 2%, that is your plus minus 1% plus half plus minus 2%, that is your plus minus half into 1, that is your 0.5%, plus minus plus and plus minus 1%, that is your plus minus 1.5%. This is your percentage error, may be given in plus or it may be given in plus minus. So this is the percentage error of the time period of a simple pendulum. Next come to your question number 3, solution. Here mass is given m plus minus delta m. This is the true value and this is the error, that is your 12.4 plus minus 0.1 kg. And your density rho, density is rho, this sign rho plus minus delta rho, that is your 4.6 plus minus 0.2. This is your kg per meter cube. We know rho is equal to, m by v. So v is equal to what? M by rho. This is your true value by true value, that is your 12.4 by 4.6, that is your 2.69 meter cube, that is approximately equal to 2.7 meter cube. This is the true value of a volume. Again we apply v is equal to m by rho, that is your delta v by v. This is the fraction, delta v by v is equal to what? Plus minus delta m by m plus delta rho by rho. You know this formula, delta v is equal to plus minus delta m by m plus delta rho by rho into v, that is your plus minus delta m 0.1 by 12.4 plus 0.2 by 4.6 into volume is your 2.7, you know, that is equal to, you calculate it, plus minus 0.14. So v plus minus delta v, that is your 2.7, this is your error limit, plus minus 0.14 meter cube. This is the third problem. Very easy. V plus minus delta v is equal to 2.7 plus minus 0.14 meter cube. Next come to your question number 4. The error in the measurement of a radius of a sphere. In the measurement of radius of a sphere is 2%. 2% means this is its percentage error. What would be the error in volume. You see, we know volume of a sphere V is equal to 4 by 3 pi r cube. You see 4 by 3 pi, these are constant, but it is given delta r by r into 100 is your 2%. So apply according to this formula, delta V by B into 100, this is the percentage error of a volume, is equal to 3 into delta R by R into what? 100. That is your 3 into delta R by R into 100 is equal to 2%. That is your what? 6%. This is the, if the error in the measurement of a radius of a sphere is 2%, then the error in the measurement of a volume, that means percentage error, that is your what? 6%. So these are the problems about error analysis. You do more and more. Today I will start units. What do you mean by units? I am telling you, the standard of a measurement. What do you mean by units? The standard of a measurement is called unit. What do you mean by standard of a measurement? Suppose you measure a length, you say it is 5. Nobody can understand what is 5. Suppose you say what is its length, you say it is 5 meter or 5 centimeter. That means when meter is added to 5 or a centimeter is added to 5, it is completely specified. That means its length is, anybody can say its length is 5 meter or 5 centimeter. So this meter and a centimeter, these are called standard. Standard of a measurement is called unit. Suppose a physical quantity is given. Let its magnitude is N1 in one system. Suppose in meter system it is N1 and its standard is U1. So you can write magnitude and its unit. So it is specified as N1 U1 in one system. Suppose that physical quantity is measured in second system. In system 2, let its magnitude is N2 and standard or unit is U2. So it is specified as N2 U2. But you see, in first system it is specified as N1 U1, it is magnitude, and in second system it is N2 U2. But you see, suppose a length is measured as a 5 meter in one system, and in another system you say it is 500 centimeter. Which is greater? We say both are same, because 5 meter is equal to 500 centimeter. In similar manner, in first system it is N1 U1 and second system it is N2 U2. So we can say, but N1 U1 is equal to N2 U2, because this is your 5 meter, this is your 500 centimeter. You see one thing, if N1 is greater than N2, this implies that U1 is less than U2. Or if N1 is less than N2, implies that U1 is greater than U2. Suppose you see 5 meter is equal to what? 500 centimeter. You see 5 is less than 500. This implies that meter is greater than centimeter. It is true or false? It is true. 5 is less than 500, so we can say meter is greater than centimeter. In a similar manner, suppose if you say 500 in centimeter, if magnitude is greater, then its unit is smaller or standard is smaller. And if magnitude is smaller, then its standard must be greater. Here is magnitude smaller, standard is greater. Similarly, here magnitude is greater and standard is smaller. Then you see, this is the unit or standard. Next you come types of unit. You see, we know there are two types of physical quantity. You go to previous very fast case. We know one is fundamental unit, fundamental physical quantity, another is derived physical quantity. What are fundamental physical quantity? These are the physical quantities which are undefined and they have only operational definition. So, what are fundamental units? There are two types of unit. Two types of units. One is your fundamental unit. Second one is your derived unit. What are fundamental unit? These are the units, these are the standards of fundamental physical quantity. You see fundamental units, these are the standard of fundamental physical quantities. You know there are 9 fundamental physical quantities. So accordingly, there are 9 fundamental units. You remember this? In international system, the units are fundamental units. Units are, first you see mass is your kg. You remember length, this is your meter. Time, international system, is your second. Temperature, Kelvin. Current, ampere. Luminous intensity is your candela. And amount of a substance is your mole. Besides those, there are two other: angle, radian. Next, yours 8 and this is your 9. Solid angle is your steradian. These are the fundamental units. You remember, these are the units used to measure fundamental physical quantities. And you know, in international system, these are the units. That means these are found at first. Your mass, what is the unit of mass? At first it was determined as kg. After that you find gram, centigram, milligram like this. First it is kg. Similarly length, what is length? Unit of length is meter. At first meter was found, after that centimeter, kilometer, decimeter like this. Next time is second, temperature is Kelvin, current is your ampere, luminous intensity your candela, amount of a substance is mole. Then angle, radian, solid angle is your steradian. These are the units of standards of fundamental physical quantity, and these are according to international system, these are discovered at first. You remember this. After that other units of mass are discovered, but these are at first discovered. Next come to your derived physical quantity. What are the derived physical quantities? The standard of derived physical quantities are called derived unit. Derived unit. This is the fundamental, this is the derived. You see, suppose you say your speed. Speed is what? Speed is distance by time. So distance means it is a length by time. So its unit is meter per second. Your SI, I am telling you. Similarly, in other system we can say speed can be written as centimeter per second, or we can write kilometer per second. But this is the fundamental. This is the SI, that is the meter per second. Similarly, I am telling you another, that is your area. Area is your what? Length into breadth. Means both are length, that is your meter into meter, that is your meter square. Next come to your volume, that is your length into breadth into height, that is your what? Meter into meter into meter, that is your meter cube. All are SI. Similarly, suppose we can say density. Density is what? Density is mass by volume. Mass by volume means mass, what is its SI unit? That is the kg by meter cube. Or you can write kg meter to the power minus 3. Like all these are the derived physical quantities. Next come to your, these are the fundamental physical quantity. The standard of fundamental physical quantity are called fundamental units, and the standard of derived physical quantities are called derived unit, like this. So now we read system of units. You see, there are different system of unit. There are different system of unit. First one is your CGS system. CGS system. CGS system, this is your French system. Next come to your FPS system. This is your British system. Third one is MK system. This is accepted by all. And their modified form of MK system is SI. SI what? International system. This is the international. Accepted by all. There are four types of systems of unit. Here CGS system, FPS system, MK system, and SI. SI means international system. First you see CJ system. In this system, length is measured in centimeter, means C. Mass is measured in gram, that is your G, and time is measured in second, that is your S. So it is called CJ system. It is also called French system. Suppose speed. Speed, what is its unit in CJ system? Speed is your what? Distance by time. Distance by time, that means distance is your centimeter per second. Next come to your density. Density is your mass by volume, that is your mass is your what? Gram by centimeter cube. Like this. These are the CGS system. Drawback of CGS system is that there are so many derived physical quantity, derived units which are inconveniently very small, inconveniently very small, which are not measured correctly. Similarly, its advantage is that what is its advantage? Some derived units are measured suitably. That means conveniently you can measure. So today I told you 4 types of systems of unit and tell you about CGS unit. So if you like my video, please subscribe it, share it, so that I will be motivated to give you better and better video. Please subscribe my video. Today's thank you for everybody.